Hello everyone, welcome back to the another video. In this video we are going to solve the series and parallel circuit of AC. Okay, now let's identify the problems, and while going through the problems, if you will follow the steps, it will be clear and will help you to solve any type of such problems. Okay, now let's proceed. In the given, let's see the question first. Try to understand question more accurately. So in the question we are given that in the given network, find what is asked, that to identify the total impedance, to find the total current, to find the current in each branch. Means first you must know how many branch we are having. This one is one branch, this one is another branch, and this one is another branch. We are having three branches. So you are asked to identify current in branch 1, 2 and 3. Okay, then asked to identify overall power factor, volt amperes means VA or apparent power. Then again you are asked to find the active and reactive power. So let's initiate. First of all, in the circuit your first task should be to identify the branch. So in the given question we are already provided that we are having the branch B to C. We named it branch 1, this one is branch 2, and this one is branch 3. So we are having three branches. Okay, and then the current is given. The current flowing in branch 3 is I, which is total current. Then I is divided into two parts, I1 and I2. So this one will be your current of I1, and then this is the current of 2. Okay, now first you have to jot down what the given parameters are. So let's initiate it. Now first let's see the parameter of branch 1. Okay, so write branch 1. Okay, now let's see the branch 1. In the branch 1 we can see that we are having resistance R of 7 ohm, and this one is the symbol of inductor, and it is of 0.015 Henry. So now write in the branch 1 we are having R is equals to, or we can write, since it's a parameter of branch 1, so we can write R1 is equals to 7 ohm and L is equals to 0.015 H. Okay, you know that this one is in Henry and this one is in resistance, and we need inductor in inductive reactance form. Okay, that's why we have to identify inductive reactance. Sometimes you are already provided with the inductive reactance. In such cases you need not to find that. Now if not given, you have to find. So to find, now let's name it XL1, inductive reactance of inductor L1. So name it XL1, which is equals to, what is the formula? The formula is 2 pi f L. For now L is L1. Now substitute the value. We are given the voltage, total voltage also with the frequency. So your frequency will be 2 pi into 50 into L is 0.015. Okay, once you wrote the formula, now acquire the value of, you can use calculator for this, and if sometimes the value of f is not given, you can assume it. You can assume 50 or 60. Okay, then you will get XL1 will be 4.71 ohm. Okay, now you have identified. Once you identify this, you know the impedance in RL circuit. You have to remember that the impedance of RL circuit is R plus JXL. Okay, so you can write this for series RL circuit. Okay, so R1 plus JXL1. Okay, now you can write R1 is 7 plus J, XL1 is 4.71. Okay, this one is your impedance of Z1 branch, or you can write in this form as well, 8. you can use calculator for this to convert your complex number into angular form. Okay, if you are having any problem regarding this, you can mention in the comment section so that I will prepare another video for this. 9.3 degree, you can easily convert this from your calculator. Okay, after identifying the complete parameter of Z1, or after identify the impedance of branch 1, now your next task would be to identify, to check what the parameters are given for the branch 2 and how you can convert them into the impedance form. Okay, now let's write over here for branch 2. Okay, and this one is our branch 2. We are seeing that we are having a resistor and capacitor. Sometimes it's given in impedance form itself, but now it's not given, so we have to convert it as well. Okay, so our R2 is 12 ohm, so write 12 ohm, and then our C2, it's in second, so our C2 is 180 microfarad. Okay, and you can convert it into farad. We know that 180 into 10 to the power minus 6 farad. Okay, now let's convert it into the capacitive reactance, which is XC2, which will be 1 upon 2 pi f. See, this one is our formula. Okay, you have to remember such formulas for the AC. If you will remember the formula, it will easy for you to perform or to solve such numericals. Okay, let's write it 50 into 180 into 10 to the power minus 6. Okay, now after solving them in calculator, you will find your capacitive reactance is 17.68 ohm. Okay, that's how you can identify the value of capacitive reactance. And now we know that for the RC circuit, if resistance and capacitors are in series, then your impedance will be R minus J XC. So R2 minus J XC2. Okay, now your R2 is 12 minus J 17.68 ohm. Okay, after identifying them, what you can do is you can convert them again in an angular form. Okay, this one is 21.37 angle minus 55.83 degree. Okay, once you identify the impedance of branch 2, let's identify the impedance of branch 3 as well. Okay, so for branch 3 you must write the parameter. We are provided with the resistance of 5 ohm. Okay, R3 is equals to 5 ohm, and then in branch 3 you can see, in branch 3 we are having again an inductor. Okay, so we'll write L3 is equals to 0.01 H. Now since we are not provided with the inductive reactance, that's why we have to find inductive reactance. Okay, now write the formula. To calculating, you will find that it will be 3.14 ohm. Once you identify, now your Z3 is also ready. You can identify the all the given data, all the provided data of the circuit. Again, let's check the whether we are having rest of the other information. Yes, we are having total voltage, which is 230 provided to the circuit, and of 50 hertz. Okay, we have used 50 hertz, but remember you are having the total voltage of the circuit. Now okay, after identifying the branch, we can easily note that what can be done. now you can check this circuit. We are seeing that this branch 1 and branch 2 both are in which connection? These are in parallel connection, because these end terminals of both the branches are connected at the single point. Okay, and if you are flowing the current, then you will see that from this point the current will divide into two parts. So the branch 1 and branch 2 are in parallel. That's why we can write that since branch 1 and branch 2 are in parallel, so their equivalent impedance, let's name it ZP, because both of them are in parallel. Okay, so we know that for the parallel branch we write Z1 is parallel with Z2. Okay, now formula is Z1 into Z2 is equals to Z1 plus Z2. Okay, now substitute the value of Z1 and Z2 and you can calculate it directly from the calculator. Now while substituting the value, one thing you need to be careful that while putting this value in the calculator, try to use the bracket 0.4. Now use calculator. If you are having any problem, again you can mention in comment section so that I will provide the related video and you will get the answer. The answer will be 7.839 angle 12.4 degree, and in rectangular form you can write it 7.656 plus j 1.68 ohm. So this one will be the ZP, while both of the Z1 and Z2 are in parallel. Now you can see that. Now let's go to the circuit. You can see that ZP was this and this one is the branch 3. We can easily see that our ZP and branch 3 are in series connection. Since Z3 and ZP are connected in series, the total impedance of the circuit is, now you can identify it easily. Okay, so work to identify the what is asked. Our question number 1 is to identify the total impedance. You can write it, since ZP and your Z3 are in which connection? In series. Okay, so we can write total impedance Z, or you can name it, we will name it Z. Okay, so Z3 plus ZP. Now just substitute their values, you will get 5. After substituting these values, you can identify the total impedance, which is 12.656 plus j 4.82. Now you can convert this into angular form as well. 3.54 angle 20.85 degree. These are impedance, so write their units. Okay, that's how you can identify the total impedance. This one is our first answer. We identify the answer 1. Okay, after identifying the value, our next task or next question was asked to identify the total current. So let's work how to identify the total current. Already provided with the voltage source. Okay, so let's work out to identify the total current. Now first thing we can do is let's assume, okay, let the supply voltage be taken as reference. Since we are not provided any angle, so we assume that it will be our reference phasor. Okay, so you can write that this capital we are already provided 230 and its phasor is reference, that's why it's of 0 degree. Okay, so this one is our volt we are provided, and you can write which is 230 plus j0. Now after identifying this, you are asked to identify the total current. So in order to identify the total current, you can use the Ohm's law. Okay, by Ohm's law, what we know is the total current in the circuit can be written as I is equals to what? B by Z, and the V is 230, and then our Z is this, which one is what? Total impedance. Okay, total voltage by total impedance will give you total current, that's why which is 13 point. Now your total current will be 16.99 so this one will be your total current. You can identify this value directly using calculator and substituting these values. Okay, now in rectangular form you can write it as a 5. Okay, that's how your next answer can be identified. Okay, now let's go back to question once again so that you can tally the answer. Okay, now we were asked to identify the total impedance, we identified it, then later we identified the total current, and our next task was to identify the current flowing through each branch. Okay, so in order to identify the current, I have copied the circuit over here so that it will be easier for you to see. Now let's in order to identify the current flowing through each branch, first you have to identify the voltage drop so that it will be easier for you. Okay, so let's identify voltage drop across each impedance. This one is our Z3. Okay, now let's name the voltage as a VAB. Okay, this terminal is A, this terminal is B, so we are identifying the voltage drop across AB, and which will be how much? You are seeing that the current is I and impedance is Z3, so voltage drop will be I into Z3. Okay, so voltage drop, now substitute the value of it. Okay, after substituting the value, you will get that the voltage drop across AV will be Now we know that by using the KVL, you can easily you can say that by KVL. What does KVL states? That from KVL we can say this total voltage is equals to voltage drop across AB and BC. Okay, so we can, by using KVL, we can say that B, if B be the total voltage which will be equals to BAB plus BBC. Okay, so you can identify the voltage, you know the value of AB and B, so you can identify the value of BC, which will be B minus BAB. Okay, your V is 230 plus, now let's write in this form, and then next one is VAB, which you had find earlier, that your VBC will be 133 6.15 angle minus 8.46 degree volt. Okay, so this one will be the voltage of BC. After identifying the value of these voltages, you can identify the current easily. How? Identify the voltage of BC. Okay, voltage, and we know that our branch 1 and branch 2 are in parallel, so the voltage BC will be same for the I1 as well as I2. So using this you can identify the current. Now by Ohm's law, again by Ohm's law, you can write I is equals to, which you have earlier identified. Okay, so we'll find I1 and I2 only. We are having two branch. I1 is equals to BC upon Z1, and this will be BC upon Z2 because both of them are in parallel. Now let's substitute their value. Okay, VBC is, this one is our VBC. Substituting the value of BBC and Z1 in calculator, solve using calculator, you will get I1 will be 15.78 angle 42.39 degree. Okay, you can use calculator, and then similarly after substitute the value of both of them. Now after substituting the value of BBC and Z2, you will get current 6.23 angle 47.37 degree. Okay, that's how you can identify the value of I1 and I2. Now you can check as well. Whether to check, you can do that I1 and I2. Okay, so check the value of I1 and I2. If you are given such question in examination, you can check it. In order to check the question, you have to get this answer, no, I1 plus I2, and check. Okay, while substituting these two, you will get I. So it shows that your answer is right. Now after that, all your task was to identify the overall power factor, D number questions. Okay, so now let's work on to identify the overall power factor. In order to identify the overall power factor, now let D number. Okay, our task was to identify overall power factor. So we know that the power factor is the angle of cosine of angle between voltage and current. Since there was no, its angle, phase angle was 0, so our phi in this question will be, now in order to remind you, our total current I was 16.99 angle minus 20.85. okay, our voltage was of 0 degree. That's why your phi will be minus 20.85 degree. Okay, so you can write the overall power factor will be overall power factor. Okay, PF, overall power factor will be, you can write it as cos phi. Now substitute the value, cos minus 20.85 degree, which will give you 0.9345. okay, this one will be your power factor. Now see the phasor, your phase voltage is having V, your voltage was V is equals to 230 angle 0 degree. okay, but our current is minus 20 degree, means our current is lagging behind. That's why we can say that the given circuit is lagging. Okay, so now our task E was to identify the volt ampere, which is our apparent power. Okay, so volt amperes. In order to identify the volt amperes, it is represented by capital S. Okay, that's why it will be V into I. Now substitute the value of total voltage, which is 230, and our total current I is, now you have to substitute magnitude only. Okay, so that's why we are writing this 6.99, and you will get that your resultant voltage is 3. So this one is your volt ampere E. Now in F you are asked to identify the active and reactive power. So you know active power is represented by capital P, and the formula is Pi cos phi. You know the value magnitude of voltage, current, and cos phi. This one is our cos phi. So substitute this value and you will get the your active power. Now let's substitute it. Now let's identify reactive power, which is represented by Q, and its formula is Bi sin phi. Okay, now our voltage is, substitute sin 20.85 degree. Okay, your reactive power will be 390.8 var. That's how you can identify the different parameters asked in the question. Now let me summarize all the process so that it will give you a clear concept. Okay, initially you are asked to identify the total impedance, so check. So first jot down all the parameters you are provided. Okay, once you do that, we can see that 1 and 2 are in parallel. That's why we identify the ZP, which one was Z1 into Z2 upon Z1 plus Z2. Okay, after that you can, it's easily visible that ZP, these two are in parallel, and then resultant will be in series with it. Okay, so we identify the total impedance, and this one was our total impedance. You can pause it and you can calculate yourself. Okay, and then next one is to identify the total current. In order to identify the total current, all you will require is a total impedance and voltage. Okay, resultant voltage or total voltage supplied to the circuit. That's why our total voltage was given, and using the Ohm's law we identify B by Z, and this, from this formula you calculated the total current, and this one is our total current. Once you identify the total current, the next task was to identify the current through each branch. Okay, in order to identify the current through each branch, means branch 1 and branch 2, because you know the total, this current flowing through the branch 3 is same total current, but we don't know how much current is flowing through I1 and I2. For that purpose we identify the voltages, because these two are in parallel connection. Okay, so we identify the voltage, and I1 into Z3 we know. Okay, voltage, the formula of AB, you identify the, you know the Z3 and you also know current flowing it. It's easy to find the voltage drop across AB. Then you already have the voltage, resultant voltage. So total voltage using KVL, total voltage is equals to the voltage drop across the impedances. So total voltage is equals to, B is our total voltage. Now we don't know the voltage across BC, that's why we find, after finding this we use Ohm's law. Okay, Ohm's law, from Ohm's law you know, since both the circuit in parallel will have same voltage and impedances will only change. So substituting the impedances, you can easily identify the current, and after identifying the current you can check it using this way. Okay, so once it happen, Now let's work to identify the overall power factor. In order to identify the overall power factor, you have to know the phasor or phase angle between the voltage and current. Now since the voltage phase angle of the voltage was 0, the our power factor phase angle is phi. Our current was lagging from the voltage, or our voltage was leading and current was lagging by 20 degree. That's why we find that the given circuit is lagging. If the current was leading, we call the circuit is a leading. Okay, now later our next task was to identify the apparent power. For apparent power, we know the voltage into current, only the magnitude, not the active power. You use pi cos phi. In order to identify the reactive power, you use pi sin phi. So you already identified the value of phi. That's how you can solve these problems. And don't forget to write the units of the parameters. Okay, so that's how you can solve the problems using basic concept. And hope this video is helpful for you. Thank you.